All right. So first of all, before I begin, okay. So before I begin, I added this joke that I'm actually not sure how familiar people are with it at this point. The Office movie with PC load letter. Or is everybody familiar with this scene of the movie? Yeah, where they have the printer and people just don't know why it's broken, and then they just have that montage of smashing it. In reality, this is programming to me. Like this is every day. We all kind of go through these phases of like we build stuff. We don't really know why it works, but it works. And at the same time, things are broken, and for the same reasons, we don't necessarily know why they're broken. There's many variables involved with programming. They may be running on different operating systems. Who knows? There's many reasons why our programs don't work as they should. So this is this beautiful headshot of me. So why am I here? So first of all, thank you for bringing me here. I'm kind of excited to be at Pi Ohio because I am an Ohio native, but I currently don't live here anymore. So it's kind of exciting to come back. I've been a software engineer in some sort of capacity for about 20 years. And I say in some sort of capacity because probably the first solid 10 years of programming was me as a child not really knowing what's going on. So there was probably the first 10 years was as quickly learning as somebody now that would go through like a code camp in probably 2 weeks. But through this has given me quite a bit of experience of dealing with and debugging things by myself and learning just how things work kind of out of necessity and kind of forcing my way through things. So today, if is anybody here familiar with Sentry? Okay, cool. So today, my day job, and probably for the past 6 years or so, I've been a core contributor to this project Sentry. I'm not going to go in and talk about it a lot in detail, but this has been pretty near and dear to my heart based on just a lot of my personal experiences of how I got to where I am. It's generally all about tools to help debug your software. So before I begin, I kind of want to ask a question. So who here does this as a professional career of some sort? I assume probably a good percentage of people writing code. Okay. How many people would claim that they're good at their job? Okay. How many people would say that they're bad at their job? I'm pretty bad at my job. Uh, and I'll say as a personal anecdote, this is something that didn't come to me right away. It was something that probably there was, mid of my career, I got pretty excited and I felt that I was pretty good at what I did, to the point where, I thought that I was kind of flawless and things that I would write, just did what they wanted it to do. And then kind of as I crested over this, I started realizing that everything I do is wrong. And like there's just so many more ways that everything I do can break. And there's just so many more variables in the world. You get into distributed systems, and that has opened up like a whole nother world of things. And kind of that self-esteem in a way has just kind of plummeted, to the point where now, in a way though, I'm more self-aware that like I feel like I consciously don't know what's going on. So doing this kind of drives behavior of writing tests. Writing tests is a really good example of dealing with that. Like that your test is going to be bad, so you just litter tests everywhere to kind of help assert that what you're doing is valid behavior. But tests are kind of flawed. Like there's tests are never going to cover 100% of your use cases. You're going to have a function that adds two numbers together, but someone's going to put in a string. Someone's going to do something dumb with this that you didn't expect, and your test is never going to cover this. And your software is going to break. So I love this quote by Taylor Swift. And to quote it verbatim, if an exception happens in production and no one sees the logs, did it really happen? And we can kind of define production as many different things. To a lot of us, it's probably shipping some web application. We ship it out there. Someone runs it, maybe it's a shopping cart, someone tries to buy something and it's broken. Or maybe it's something that is just a script that we've given to our friend and they run it and it doesn't work. So production can mean a lot of things. But if we don't know and we don't experience this happening, or someone doesn't tell us that this has happened, we don't really know that it happened. So this kind of drives into the story of, that we've probably all at some point experienced, and if you haven't, you will experience this problem. You'll give someone this software, someone's going to say this doesn't work. And you're like, well, it does. I've run it, here it works. But the problem here is you're missing a lot of context about, and they're not necessarily sharing all of this context. They don't know what operating system they're running on. They may not be, varying levels of technical capacity to even explain the problem correctly. But you're just kind of left in the dark of saying, well, I fired it up on my machine and this works. So to kind of explain this process, and we're going to talk a little bit about some computers. So I was going to do this in a little bit of x86 assembler, but I've thought that a little bit of diagrams would kind of explain this a little bit simpler. So for those that are not aware, and I don't expect this to be common knowledge, like we don't deal with this stuff on a daily basis, but we're going to go through just a very, very high level, very quickly. It's also glossing over a lot of details of how we tell the computer that we want to open a file. And if we can imagine, opening a file has many problems. File doesn't exist. Maybe you don't have the right permissions. There's many reasons why this might not work. So to quickly go through, we're kind of, we feed this information into the computer. We're saying we want to open this file. Here is the file name that we want to open. This is the mode that we're going to open the file as. Now we're saying, hey, yo, hard drive. Here's the shit. Give me what I'm asking for. And what happens is the hard drive, you don't have a lot of direct communication with this external device. It's a separate thing. It's not attached to, or it's attached, but it has a wire. So you're communicating over some interface. And this interface ends up writing back a response code. And if we can imagine, this translates into higher level programming languages as well. You have Python, you have your JavaScript, whatever. They return these values that tell you what that is. So this is kind of fundamentally what is happening with a computer. This is how we've gotten an error back that says that we don't have a file. So now if we jump into something that potentially we're a little bit more familiar with, and we go into C, and C is now providing a couple more abstractions over this. They're giving you this interface for opening a file. You could approach this again at that same lower level, but we're going to try to start glossing over things at a little bit higher level. So here, this is a broken program. So does anybody know off the top of their head what's going to happen if I try to run this and foo.txt does not exist? This is C. We're going to segfault. So we'll get something like this. And the problem here is that the fopen did not respond with something that we expected. Like we're expecting this file struct, and we actually got back null. So now we try to operate on this null, and the computer's like, I don't know what to do with this, and it segfaults. So we kind of have to, build this guard around by checking what this return value was, and then, conditionally do this behavior. So this is kind of some fundamental error handling that we do. So if we move over to Go, this one's a little bit of a trick question. So does anybody know how this would behave in Go? Bingo. This one actually doesn't do anything because the file object that is returned is effectively able to be no-opt and worked on as it is a file. It just doesn't actually do anything. So in a way, it's kind of a good thing, but it's also an underlying way of just how Go functions. But Go has the same similarity that it returns an error, and you're supposed to handle this error in some way of checking in this case. If it doesn't equal nil, you can return it, and then if not, you go proceed and read the file. So if you move over to Rust, Rust is actually a little bit more interesting. So Rust, this is actually kind of hard to do. If you're not familiar with Rust, and I do not blame you if you are not, Rust at compile time tries to it absolutely makes sure that you are handling all of these cases. It will not let you get to a state where you can have a nil pointer. It will not let you get to a state where it's just going to blow up. So in this case, if we notice the dot unwrap at the end, this is telling Rust, I don't care. And this is the and if you are new to writing Rust, I promise you, you will be putting unwrap on everything, because it's a little bit verbose to work around things correctly. But if we go and we run this code, we get this error, and we have the option to spit out this backtrace, which is pretty familiar of something that we're used to in Python. But if we want to correctly handle this in Rust, we have to do something like this, which is kind of similar in the way to how Go did it, but basically we have sort of analogous to like a switch statement of the OK path and then the error path. And we're required to handle this stuff for Rust to even compile. So it's kind of nice. Now we move over to Python. So we should all be pretty familiar with what's going to happen here, right? We're gonna try to open this file, and it's immediately gonna raise an exception. And we're gonna get something like this. This is what we're familiar with. So if we want to handle this in Python, we probably all know we're gonna accept this IO error. We're gonna pass, and then if things work correctly, now we're gonna proceed with our operation. So the key thing to point out here is that this is an exception as opposed to an error. So what does this mean? So errors are basically that return value. It's something that the function returns. We're able to introspect that return value. It also does not halt our program. We're able to have multiple errors that are coexisting. We could try to open 20 files at one time and then check all the errors later. There's nothing that's preventing us from moving on in code. Whereas an exception in Python, as we all should be aware, an exception is fatal. An exception is something that requires you to handle this at this time. You cannot proceed with more code within this same call stack until you have explicitly said what you want to do with this. So if we go back to what is this exception that we're looking at, let's start diving in and say, like, where does this come from? How does where does this information come from? What does it look like, and what's it do for us? So if we go back to we just ran this program. The first thing that we could do is there's this main level except hook, and this is the highest level when your program is going to crash, meaning you have this exception that you did not handle in any sane way. There's this high level except hook. But we can intercept this except hook, and we could say whatever, we could do whatever we want with these values, and we could at this point start debugging or spit this out in different formats. So if we start out and let's just print these arguments that we get the type of the exception, we get the instance of the exception, and we get this really cool traceback object. So if we dive deeper, now let's try to reproduce the output that we actually get from the console. Well, there's this convenient traceback.print exception that we can throw in there that takes those same arguments that will give us this exact string. So we've been intercepting this at the global level, but now what happens if we want to effectively log this? If we want to capture this exception, handle something gracefully, move on, but we want this output? Well, we could do something like this. So inside of our accept, we can access those the three tuple of exec info. And this will give us back the exact same IO error, the instance of the error, and this traceback. And to be verbose, we could do the exact same thing. So we have print exception, here are the bits, give me the output. Except in this case, our application won't actually explode. But now we know that it happens, and we haven't gracefully moved on. So this exec info is kind of, in a way, abusing the fact that exceptions are these things that only exist one at a time. So we can run sys.exec.info at any point in our program. But if we run it outside of an exception, we get nones. If we run it directly outside of the except, we also get none. So this is very important that this exec info is taking the fact that there is one exception that is at runtime at any point in time. So if we do it within our except block, we get the exact same output. So we have the exception type, we have the exception instance, and we have this traceback. So let's start taking this traceback and let's start doing something with it besides just printing it out to our console. So there's other options of dealing with this. So we can print this exception to a file. In this case, we're going to do standard error, which is basically the same thing as we've been doing. But now we have something that's a little bit more sustainable. We could run this program. We could dump this to an error log. And now we have all of our errors, right? All of our problems are solved. We have all of the exception data. Until we look at this file. You have this. And if you're running some web application, something with a lot of data, this can be blown by. Like if you tail a file on anything with a high volume, it's nonsense. So that was a contrived example, but let's look at what an actual, here's a key error. So from this, we should be familiar with kind of what these pieces are. So if we break it into one individual traceback, we can see these are really the key pieces that we need. We had this things variable of some sort. We have a key error of thing3, but we still don't really know why. Like we know that there was a key error, but we don't know why there was a key error. It should be there. So now we go back to our story, and we get this error log, and someone says, "Hey, this ain't working," and you say, "Well, it should," and then you get the traceback, and you're like, "Well, that should be there. I don't know. Like, what you're doing something weird. It's not my fault." So this other really interesting thing that we can do in Python, and I'll say I used to take this for granted. This is not a thing that is easily accessible in other languages. You could do it in Ruby, but in Ruby it's extremely expensive. But you could introspect. There's these magic functions, globals and locals. So globals is kind of as you would expect, and that will dump out a dictionary of global values in your module. So you'll see everything that was exposed at, so you would see key and you would see things. Then locals is local to that frame. So if you're within a function, it'll tell you the variables that were in scope of that function. So if we look at this output now we're starting to get something that's a little bit more useful. We can see that, here's our things, it was an empty dictionary, key was thing, blah, blah, blah. We can kind of make a little bit more sense now of why we got this key error, because we have the actual values. So if we take this a step further, compounding on what we've been learning, we could start to do something like this. This kind of goes into a much deeper topic of actual structured logging. So a good friend of mine, Heineck, has a really good library called structlog. I would absolutely do not do this. There are many reasons why just trying to JSON dump all of this garbage will fail. Use a library that does this. Don't do that. But the value here is that once we get this into now a machine readable format, we can start doing other things with this data. We can say, shove this somewhere else. We can shove it into Elasticsearch. We can shove this into a service like Sentry, or anything else that can actually consume this data in a reasonable way. So if we go back to, now a little bit more complex of a program, we see that we're going to get a problem. So here we're gonna get this thing. We're trying to get a random number, and then we're going to do a key error. It's kind of contrived, but we're going to show that just having these local variables is not as useful. So we see that our index here was 8, but we don't know anything about, we don't know how it got there. We only see that one scope. So this brings us to how we can, kind of dive into this stuff a lot deeper. So throughout this, I've shown this traceback object. This traceback object is extremely in depth of what you could do with it. So here is an example of taking, we run this debug function, and as we see, we're going to actually extract this traceback object, and you can walk up this traceback object through all of the frames in your stack. And at this point, if we step through this, we can get the frame of code, and then we can actually extract this code object out of our frame. And these frame, traceback, and code objects have all of these primitives that are needed for constructing that textual stack trace that we saw at the beginning. So now we can kind of keep going further and start splitting this up into more and more useful bits. And there's a lot of stuff that if you really want to dive into these code objects, there's a lot of stuff in there. I think I don't need that variable there. That's a good observation. Definitely don't need that variable. Well, it is the while. So the traceback will keep looping back on. So there's a TB next of next frame, and you can keep looping back on yourself. TB next. Oh, no, the actual iterator next? No. So now if we get this, we have something like this, right? So now we have each of our frames of our function. We have, now we can extract the actual function name. We can extract the line number. And if we noticed, we can get frame.flocals. And this is pretty clutch. So you're able to walk up every single frame of the stack trace and extract that dictionary of local variables for every single frame. So now we get something like this. And we, now this is basically all of the information that we could potentially get out of that little primitive program. So the next steps are, let's get a lot more information, right? So now we have the case of we've run this program, we have these variables, but there's still a lot of things that we don't necessarily know that are kind of implied with the environment in which this runs. And this is all a lot of stuff of context. So once we've gotten to the point where we can, structurally log this stuff, or we can do something, extra with this, we can now start collecting all of this information that, whatever we would need to help us in this situation. So in this case, we're going to log, the arguments that were passed in through the command line. We're going to actually extract all of the environment variables. We're going to extract the host operating system information, and we're going to extract the time that was run, and all of these things. What we're trying to do at this point is just get all of the information to help us actually try to fix this problem. If we kind of expand on this, we can pull this out to, say, a web application, right? A key thing of a web application would be knowing what user triggered this error. Maybe what HTTP endpoint did they use to trigger this error? What state was their session in when they triggered this error? There's a lot of other information that we need to put together to actually get the full picture of what happened. So now ideally, once we get to this stage, we can actually see, oh, you're running on a really old version of Mac OS. Why is your clock skewed 5 hours from what it should be? You can start learning a lot of this information about, this environment. And now we could take this report, we expand on it, we, collect all this information. And I'd like to point out, it's really cool standard lib. If you're trying to read a file and you want to get lines out of a file, there is a line cache library that is built into standard lib that is used internally to render tracebacks. And it just keeps a little it's not even LRU cache. It's literally when the cache gets this size, flush and just restart. But the idea is that we can use this to our advantage to extract lines out of our file without hammering our disk. That's pretty cool. And now, at the end of the day, we have this really nice report of all this information. And we can just, this is pretty simplified, but we can now email this to ourselves and say, oh, we saw this exception. Here is all of the information that we need to do with this. So kind of in summary, that's, our jobs are pretty complicated. There's a lot of variables. There's a lot of ways that production systems differ from how we run things on our computer. The testing environments are very different. As I said at the beginning, tests don't cover a lot of stuff. If you've been shipping things into production for, since day one, you're going to learn that somebody wants to put in an emoji for their age. And you're going to hit these problems that you just absolutely never anticipated. And these aren't things that necessarily make us bad at our jobs. It's really hard to understand and be able to anticipate all of these use cases. But it's important that we can build and design things to be a little bit more defensive, so we can kind of step in front of these and catch them. So the first time that we see someone do this, imagine someone does that. They put their emoji as a name. You can now reach out to this person and say, what are you doing? Why'd you do this? And you can actually be responsive to that instead of waiting for this customer to be, this is broken, and then complaining about this, or yelling on Twitter and saying, hey, yo, shit's broke. But no, you put an emoji as your name. Like, stop. So the little sales pitch here is that this is what I do. Like, I've been doing this for a long time, and we've been developing this software that helps us do this. All stemming from the fact that we're pretty bad at being software developers, and that's not anything to be ashamed of. It's just there's always a trade-off of doing everything 100% right. I'm not shipping stuff to the moon, or something that's that mission critical. I can deal with the occasional exception. So this has kind of been a passion for me for it's going on 7 years at this point of building software that does this for you, all because I'm pretty bad at writing software, and I've kind of resignated with that. So essentially, that's just kind of what we do. So generally, like, you probably don't want to do all of this stuff yourself, but it's nice to know all this stuff is there in Python. This doesn't exist in other languages, so congrats. So again, I don't really know what I'm doing, but if you have any questions about all of this, I live and breathe it, so I may or may not have answers for you.
So in the frame locals, what about sensitive information?
What about it?
Well, so if I'm processing credit card numbers, shouldn't be touching that, but I'm doing it, and it's in my frame locals, and I ship it off to a third party. What does that look like?
Yeah, so in this world of what I've shown, you will be sending that. In the real world, you would have, like, there was a magical serialize of this report. If you were writing this, you would probably have in the serialize something that is generally scraping on patterns. You would say, oh, this looks like a credit card number. I'm just going to plow through this entire dictionary of this report. If it's a credit card number, redact it. Or anything like that. If you have sensitive keys, so using Sentry, for example, there's a lot of keywords that we'll use that just kind of throw red flags. If it's auth, password, like obvious things that we'll try to extract before sending it. Also because that information is generally not useful at the end of the day unless it happened to be the fact that they were putting in a credit card number of emojis is what caused your problem. There's pros and cons. Either you collect the credit card numbers or you sacrifice some information. That's true. If it was your own and you were putting into your own Elasticsearch. Any other questions? Yeah. I will honestly say no. Python, for all of this world, so Python is by far the best. Ruby has some pretty similar stuff that you can do, but Ruby has a very heavy performance impact at runtime by enabling this feature, so people generally don't. I don't know all of the technical details of why Python does this for free. I assume they just absorb the overhead just into the runtime, since there's not really a way to disable it. It's a little bit more transparent. To answer that, though, I'll say the flip side of this is other languages that don't have this stuff. So JavaScript is one that stands out, and that was the original inspiration and the first talk that I gave about this. And JavaScript is it's a lot more entertaining, I'll say, especially of like a talk, because it's just a trash fire, like trying to do this type of stuff. So that talk is a lot more of just like, you have to go through so much effort to get anything that is useful out of this. So for example, when you get an exception in JavaScript, there's this nice convenient exception.stack, which is similar to the traceback, but in JavaScript, this is a string, and there's no way to introspect this string any other way. So you can plow through with a regular expression and kind of extract the pieces that you need out of it, but every browser does their own thing. So every browser has their own format. Every browser has their own way of doing things. They evolve things over time, but there's definitely no way of getting local variables or anything like that. And even getting stack traces in JavaScript is not as trivial as this. There's a lot of complexities involved in that as well. There are. Yeah. So he asked a little bit more information about Sentry and if there are any competitors out there. I'm not a marketing person, so I'm going to avoid the competitor question. There are competitors out there. I will say, almost objectively, we've been around for the longest. For sure, not necessarily to say that that is necessarily a testament of quality, but we've been doing this for a really long time. Yeah, so Sentry is kind of fundamentally all of this stuff kind of wrapped up with a really nice bow on it. So our goal is getting you to giving you the information so you can actually fix a problem as quickly as possible. And all of that is kind of, this was centered around context and getting context. A stack trace is not, by itself, is not enough for you to always solve your problem. So it's getting stack locals. It's, being able to add your own metadata to stuff, stuff that we don't know about. Getting the HTTP request information, getting the query string arguments that were passed, getting the user information, and getting all of that stuff, and then tons and tons of other metadata. So our goal is being able to get you to, you look at it and you say, oh, that's why. And maybe derive a pattern and say like, oh, these types of people are all doing the same thing. Oh, they're all from some other country. That's a problem, or something like that. And you can kind of identify, those types of characteristics to kind of, all this stuff to help you actually fix the problem. We could talk offline about this if you want. I'm generally trying not to be. He's asking about our product of like one of our tiers and saying how much, what does 10,000 events a month mean? To be clear, I'm not here to sell Sentry, but I will talk with you about it after if you want. Anything else? All right. By myself and learning just how things work kind of out of necessity and kind of forcing my way through things. So today, if is anybody here familiar with Sentry? Okay, cool. So today, my day job, and probably for the past 6 years or so, I've been a core contributor to this project Sentry. I'm not going to go in and talk about it a lot in detail, but this has been pretty near and dear to my heart based on just a lot of my personal experiences of how I got to where I am. It's generally all about tools to help debug your software. So before I begin, I kind of want to ask a question. So who here does this as a professional career of some sort? I assume probably a good percentage of people writing code. Okay. How many people would claim that they're limited? To the point where now, in a way, though, I'm more self-aware that like I feel like I consciously don't know what's going on. So doing this kind of drives behavior of writing tests. Writing tests is a really good example of dealing with that. Like that your test is going to be bad, So you just litter tests everywhere to kind of help assert that what you're doing is valid behavior. But tests are kind of flawed. Like there's tests are never going to cover 100% of your use cases. You're going to have a function that adds two numbers together, but someone's going to put in a string. Someone's going to do something dumb with this that you didn't expect, and your test is never going to cover this. And your software is going to break. So I love this quote by Taylor Swift. Good at their job. Okay. How many people would say that they're bad at their job? I'm pretty bad at my job. And I'll say as a personal anecdote, this is something that didn't come to me right away. It was something that probably, there was, mid of my career, I got pretty excited and I felt that I was pretty good at what I did. To the point where, I thought that I was kind of flawless and things that I would write, just did what they wanted it to do. And then kind of as I crested over this, I started realizing that everything I do is wrong. And like there's just so many more ways that everything I do can break. And there's just so many more variables in the world. You get into distributed systems, and that has opened up like a whole nother world of things. And kind of that self-esteem in a way has just kind of plummeted. All right. So first of all, before I begin, okay. So before I begin, I added this joke that I'm actually not sure how familiar people are with it at this point. The Office movie with PC load letter. Or is everybody familiar with this scene of the movie? Yeah, where they have the printer and people just don't know why it's broken, and then they just have that montage of smashing it. In reality, this is programming to me. Like this is every day. We all kind of go through these phases of like we build stuff. We don't really know why it works, but it works. And at the same time, things are broken, and for the same reasons, we don't necessarily know why they're broken. There's many variables involved with programming. They may be running on different operating systems. Who knows? There's many reasons why our programs don't work as they should. So this is this beautiful headshot of me. So why am I here? So first of all, thank you for bringing me here. I'm kind of excited to be at Pi Ohio because I am an Ohio native, but I currently don't live here anymore. So it's kind of exciting to come back. I've been a software engineer in some sort of capacity for about 20 years. And I say in some sort of capacity because probably the first solid 10 years of programming was me as a child not really knowing what's going on. So there was probably the first 10 years was as quickly learning as somebody now that would go through like a code camp in probably 2 weeks. But through this has given me quite a bit of experience of dealing with and debugging things.